So now we're opening for questions. I don't know, like I have only see one question in the OVA, is that right? Or am I missing the place that to find questions? The student volunteers? Yeah, all right, okay. So there is actually, the question is, what is IoT and what is not IoT? So, and there is a great variety in this session, and they're right. That would be my question too. So if anybody would like to start and discuss their view about what IoT is actually. And if you don't mind, I mean, the panelists, if you don't mind to, and if you have possibility to turn on your cameras would be great, because it's, you know, like it would be a little bit more natural than speaking to a black screen.
If nobody jumps in, I will do. Miguel Weigel. I think IoT is exactly what the word says. The Internet of Things. So the things must be a thing, yeah, and not a computer. I think that is especially for us as UbiComp, yeah, an important boundary, yeah, that we have towards like the gadgets, let's say, yeah, which are basically obviously computers which require some experience to use them, etc. And with the Internet of Things, basically the computer steps back is a secondary functions, so to say, not be seen. You concentrate when you use, for example, the earbuds. You concentrate on having the audio, or just having them for blocking the audio from others. And this is a thing, obviously, which has additional function. It can measure something about your health, for example. You can access this function later on, or summary, or you be warned if there's something dangerous. But it's not visible. Yeah, it does not. It's mentally disappearing. Yeah.
All right, thank you, Mark. So I, you know, like Gregory has introduced this computational material or Internet of Material. So, and I wonder, yeah, like what is the difference? Or is there any difference between these two concepts? I yet to read Gregory's paper, but I mean, it is sort of seems to me that, you know, like it's the same vision of UbiComp, you know, like disappearing things or having everything embedded, all this digital interaction, and everything becomes sort of an interaction device. So I wonder if there are any opinions about this.
Sunny, may I add to what Michael had just said? Sumi Hilal here.
I see.
So I would agree with Michael. I mean, on his definition of IoT, but I would like to add that IoT really represents a promise. It's an opportunity, because if we have just things that are connected, there is no IoT. We already have that for a long time. It is the idea that combining these small, as he said, non-computer elements, they are small in their own, but combining them is where the value of IoT is. So when we say Internet of Things, it's just becoming a numbing phrase. We really should focus on the value of the IoT. There was old research about the value of the network. You know, when the Ethernet came, what is the estimated value of the network? Now we talk about the value of the IoT. What impressive opportunistic scenarios that might come out of a bunch of things by just them combining together. And to your comment about, well, what is the difference between this and UbiComp? Well, they may not know, there may not be any interface at all. There might be just simply things that happen. We have seen traces, and we've seen trying to exploit these traces into doing something. So just things can get together to do something that is either opportunistic, even unprecedented or unexpected. But there is that element of a promise, surprise. It is more exciting to let the IoT sort of inform what the opportunities are. Without that, having just things that are connected, all connected things together, that's just a stovepipe approach we had for a long time, but it doesn't really add anything.
Right, right. So, I mean, just if you have any opinion about this, so would you see the computational or Internet of Material as a subset of Internet of Things or a subset of UbiComp or something different? Do you have any insights into that?
I mean, given our paper today,
yes.
I don't want to be personal, but given our paper, we actually cross the line and say IoT should not be a bunch of small hardware.
Right.
We would be missing significant opportunity if we don't treat mobile apps as things, because they are very opportune. They have interface points. You can inject yourself into the IoT app. So we are crossing the cattle guard to declare that other things that are unthought of could also be part of the IoT. So I do not exclude the work by Gregory and other colleagues on smart material and or printable hardware and all that stuff. They could definitely be part of the IoT.
All right, thank you so much, Amy. And let me see if there are other questions coming in. Yes, so I see. What are your thoughts about on-device computing in IoT?
So probably I transfer some knowledge from a session that happened yesterday, and it was about energy harvesting actually, and there was an argument that this must happen, and the reason is that this way we are able. When you distribute it, we have distributed elements, and these distributed elements may be able to being self-powered because they are small. They can be made self-powered, and then if you distribute load on these self-powered devices, you will basically the hope would be that you save a lot of energy, which is required because we have to reduce energy consumption overall, and this is an interesting argument in favor of that. I just want to jump in. It's not from me. I just transport it.
Thank you. Anybody else would like to comment?
I think one great challenge with the IoT devices doing edge computing is that with all the very complex machine learning models, the question is how much you can offload actually to the edge, and we have to find, I think, smart ways to actually do that. For example, just for the earable computing, if you have simple gestures that your earbuds should detect, I mean, the MCUs in there are rather small. So you need simple models and predictors or recognizers or whatever. So such functionalities, they actually have to be taken out of the internet into the hardware, and then you can do pre-processing in such cases, and then maybe compute just the high-level information to the internet, where the users actually then can see it on their smartphone or whatever.
Thank you. Others? No, okay. So I also have a bunch of questions, but I'm reading as questions are coming in. The next question is, one of the core tenets of UbiComp is the idea of technology fading to the background, which can lose discoverability. Is it as simple as giving people instructions ahead of time, or can we do more? Well, Sumi, would you like to?
I just want to say that if the person can clarify further, because the question.
Yeah. Yeah, actually, I wanted to ask that too. If the person asked the question can please clarify what they mean. I'm wondering if they can speak in the live session. Alex, is it possible for people to start the audio?
I was the one who asked that question, actually. And
Okay.
I'm making it broad on purpose because I think when we're thinking about all these devices being connected to, I mean, there's a couple of ways that I word it broadly on purpose to try to encourage conversation, because I think this can apply in a couple of different ways, right? So for the earables, for example, it's not like there is a visible interface that someone can look at and to know that there are particular gestures or motions that they can do. So how does the person know that ahead of time? Are you handing them an instruction manual or a video that explains that to them, or is there something more? Many of the other papers talk about how do you link multiple devices or interfaces together. And again, are those really obvious? Is there some way that we need to explain that? Do we assume that people know how to do those ahead of time? I think as we move through the years and we think about the different combinations of interfaces and devices that come together, these challenges keep on popping up in different ways.
Thank you, Alex.
I would like to take a stab at this. Definitely an excellent question. And no wonder it wasn't very clear from the start. And that's because of this line that you try to draw about how much you want to tell the user about what the IoT is and how to use it, and how much you want to give instruction, how much you want that to happen intuitively or naturally. And if you do it too intuitively, it might just go above the head. People may not even know that the IoT exists or the opportunity exists. And if you get to be more prescriptive, it takes a toll on people to use. So that's an excellent question. I don't have an answer for you, but just use cases and studies are needed to do that. The example that was given by Wyatt this morning about coffee maker. So you go to bed, you set up your alarm, and as you set the alarm, the application now, because it's a mobile app, the thing tell you, would you like me to set up the coffee maker? That's intuitive. You say yes, but how intuitive can you get? So I would like to reinforce that question, that we need a lot of research to understand that element, the boundary between intuitiveness and prescriptiveness in IoT. Excellent agenda item to move forward.
So Sumi, related to that, yeah, I appreciate your comments. The paper mobile apps as things in the IoT, I found it really interesting to think of, mobile apps as things. So now I'm thinking, previously we said that IoT is a set of things, like the physical things, not computer. So given that mobile apps are actually digital entities, the application, and they don't have a physical presence as such. So how is it that they can be part of the IoT? Is it something that we are now mixing the IoT, both including physical and digital, or what are your thoughts, perspectives about that?
So it's very simple that the more we put restriction on IoT and try to define it,
right,
specific kind of species, the more it becomes limiting. We feel people are a part of the IoT, apps are part of the IoT. Ahmed Khalid, who's an author, co-author on this paper, he listened to my complaints all the time about, the World Cup, because that happened to me in 2014. I couldn't watch Germany and Argentina. I think that was the game. And I had a big meeting and I got pulled into it. I couldn't really record it because I had to play with these remotes. So it was a big gripe. And he went ahead and actually prototyped the idea that, if the app is part of the Internet of Things, if it considers itself a thing on equal footing with the DVR and the TV, then it could actually possibly get things done for us. Because that's the idea, is to get the IoT to do things for us, exciting things. So absolutely, we feel that mobile app is a first-class citizen thing, and it should be, and other things should follow, not just match, but other things should follow. We should not restrict it. The more we be open, the more we'll have interesting scenarios and opportunities in the future.
Great, thank you. Other comments or opinions?
Yeah, I mean, I would probably slightly disagree a little bit with a viewpoint. I think it depends a little bit on the app if it is disappearing or not. If basically from what you see when you open an app on your smartphone is only the functionality of the app, because the way the whole system is constructed, basically all other functionality except for the part on the top, yeah, is going to the background, and you see only the functionality of the app. If the app is good designed, basically you only face this app thing in your hand, and it's not a smartphone anymore. It's this app which is materialized in this general purpose device thing, say, yeah, but is perceived as this app, and that is an important let's say decision point where we can say this is an app which is really a ubiquitous computing thing, or it's only a computer. Yeah, I think that is really the difference. But I found the initial question from the audience very interesting. How is it? Do we have to learn more things? Yeah, for the smartphone, we have to learn a lot of gestures actually. Yeah, if I hand out the smartphone of today to a person of 20 years ago, he would have his difficulties to use it. We find it easy, yeah, but we learned it, yeah. We learned all these gestures, and I guess for other computerized things, which may have a little bit more functionality that they had before, like you had a headset which is not only playing the music, but you also now have a few buttons to switch it off and on. Yeah. In future, you will most likely do, or even now you do this, and we will learn. Yeah. Such novel types of interactions, yeah, because of the possibilities that we have. Basically, also interaction will converge, and probably as they are more and more context aware, it will be sort of, they will integrate themselves more in to our everyday lives, and things will be half automatic, yeah, and things will get more implicit. Also, your usage behavior will probably be more implicit, and there we are crossing explicit interaction, and will be more and more implicit, because we do it like we drive in car. We don't think about using the gear or so, yeah, we just drive. Yeah? The same way we have to develop also the things around us if we want to computerize them. Otherwise, we will just get mad, all of us.
Thank you. Yes, Samika.
So that's an excellent point, Michael. I think what you're saying suggests that a potential answer to Alex's question is to try to be adaptive from the outset. We have to follow an adaptive design, where initially, or for certain user groups, you're more prescriptive, instructive, but adaptive in the same time, so that when obviously the user doesn't need that, it just takes a back seat. And I think Takeo Kanadi from Carnegie Mellon, he had that famous formula about assistive technology and assistive interfaces, which is, don't look at only the deficit or the disability, but also you have to subtract the ability. As people's ability increase, don't over-assess. He has that famous formula, so that evoked that formula again. So it's an excellent remark you're making on Alex's question.
Thank you, Sun. Any other comments on this? And I think related to that, I just wanted to mention also, I find it, like the rule base, part of the papers, I don't know if the author has any opinions. So if we still have to, code the rules of how the device should operate, like what is the point? So it's still a burden on the user or the developer to do that. So do we ever get to the point that is actually, so that the device can actually sense the environment to set the rules automatically? I know there are work out there, like they have touched on this, but I'm not sure what the state of the development actually is.
I mean, I think for the start, just in the context of hearables, there's very clear cues that could be used to capture context. For example, if you have an incoming call, you can have a set of reduced gestures just for this functionality. And so over these very clear contexts from different applications that are kind of brought onto the user. For example, also based on certain surroundings, there is an hearable paper that we have in the review where they use BLE beacons to also change the voice tone of the user and the surroundings to increase the speech level of the user. So I think there is there's definitely people looking into that, and it can be realized with pretty simple sensors on a basic level. And then the question is, how complex can we make this? How great is the context that we can actually infer from all the sensors that you usually might be having, or that the house has in the context of IoT, to adapt and then provide the functionality in the right moment.
Thank you, Tobias. Other comments before we get to the next question? So there's another question specifically to this to the paper on using mobile phones or phone batteries as thermometer, which I personally find it very interesting. One of the questions is that, or the comment is rather, they et al. Investigated users' proximity to their smartphone in 2011 paper and found that the battery temperature can be a key indicator of the proximity. So there is a question what they think about it, and I also have follow-up questions, but let's hear first the comments on this.
So yes, so we did tested the let's say the overall performance when we put the mobile device at different, let's say, contexts. For example, let's put it on the table, put it in the user's pocket, okay, pen pocket, or even just in the bag. And then the results to say, in general, shows first thing, the feasibility. We can still test, let's say, have an estimation about the temperature. And also we do observe, let's say when we put this thing in real life usage, that to say when actually the context switches, right? So let's say when I put my phone on the desktop and then when I, on the desk, and then I'm let's say going back home, so I put it into the pocket. So there's those kind of transitions. Those things will temporarily increase the error or the loss of accuracy. So that means when we are doing this kind of thing, the context of the phone, whenever they change, in this particular case, that means the change of the surrounding environment. But it could be also in other contexts, let's say when I just turn on another application, right? So that's the context of the phone battery changes. If you cause the battery to leave from the stable state to the transient state in terms of the thermal behavior. And that kind of a disturbance of the thermal state will enlarge the estimation error for a short time. But eventually, as time goes by, let's say when the conditions stabilized or converged again, the accuracy can be automatically recovered. And also to shed more light on this kind of thing, we also have a statistics to say because we have those real life usage, we have a lot of samples. We have a huge amount of estimation at different sample at different times instance that corresponding to different battery thermal behaviors, transient or stable. And then we compare the performance when we do the estimation when the battery is stable. And we compare that with the estimation when the battery is in the transient state. And then the result is clearly can be seen. If it's a stable battery, let's say thermal state, the estimation is much more accurate compared to the transient ones. So yeah, that's actually the some kind of insight from this kind of thing, because we do have different methods to tackle these stable and transient thermal states of the battery. And then on the other side, if we compare our design or maybe the algorithm with those off-the-shelf applications, okay, we do have noticed a significant improvement of the performance. And this result, compared to what we have just seen, they lead us to a conjecture that those kind of applications, they can download it, very likely they only covered the stable state estimation. They are missing the transient state analysis. And then what our design covered that part, but still we can show it, because that's actually the technical, that's the physics, right? Then things change when we want to do estimation. That's much more challenging. Yeah, so will be the key challenging part.
Thank you. So related to that, so you're talking about the effect of the external events on the, like battery or temperature, reading temperature. I also wonder if, if we are able to distinguish between the effect of, like internal processor and usage of the phone itself. So that also makes playing games, or for example, or using different applications may make the battery, heat up, right? So how do we distinguish between the two, between the, reading the temperature and the ambient?
Yeah, so here's we can take, so in general, the comment is that it's a yes. Of course, we want a yes, but let's be more clear. What we can do is to say, we can tell if this, let's say, in the various statistics, it's quantified answer, we can tell if the current power consumption is large or not from battery temperature, right, or battery heating behavior. And then if we have other knowledge to say, because for example, as in our experiment, we tested the phone usage in different scenarios, right? So we have playing YouTube, we have played a video game, listen to music, and also the idle state. If we have those kind of, let's say, knowledge to say, hey, we are talking about these 4 categories or 5 categories. And then based on the battery's temperature, that means from the temperature, we can know actually the load intensity. Then we can do the classification. That's the takeaway, I would say. So I cannot claim that, say, with our application, if you use it in another way, we can say, based on the battery temperature, how you are using the phone. Oh, that would be too much fine-grained estimation. Right now, there's no way we can do that. Yeah, we can say you are discharging a battery at a very high load intensity, in a mild, medium load intensity, or maybe you are idling your phone usage. That's something we can tell. Yeah.
I see. All right, thank you. Great. I have other questions. I don't know if anybody would like to add any comments to this, or we can move on to the next. So I have also a question about the first paper in using IoT inspector. Also found it really interesting work, and I first of all, I think the data is very important, and so the other question is that I wonder if this IoT inspector itself, like introduces some sort of privacy and security holes into this network. So as I understand it, is like you also hack the traffic, right, in order to gather the data. So what if this IoT inspector is somewhat hacked itself? So how do you protect the data that you're gathering? I'm just curious.
Yeah, in fact, the way we collect traffic is known as, in the industry, art poisoning. It is an attack itself. And we're taking advantage of this particular technique to make it easy to collect traffic. Regarding user privacy, we do several things. Number one, we only collect data that is absolutely necessary for research. That is only headers, no payload. We don't ever collect the IP addresses from users. We don't know their email address. We don't know anything else, only the headers. Even if our servers get hacked, in the worst case, the attackers will get hold of headers, some unique identifiers that are generated randomly per user, but the attackers won't get hold of things like the user's IP address or emails or names or nothing. So we're trying our best to secure our data.
Great. So I mean, but the data that you have available, I wonder what can people do with the data. So I thought at some point you said that the data would be available to researchers. So what are the use case scenarios you think this data can be used for?
One of the active projects we're working on right now is developing firewall rules. For instance, when should we block an IoT device's traffic? When an IoT device is talking to domain A, is domain A really what it should be talking at? So the way we look at this problem is that we look at the data set, look at all IoT devices of a similar vendor and model, and see if they talk to domain A. If some threshold devices talk to domain A, then domain A is probably okay. So this is one example of the kind of work that can be done using this large-scale data set. So it's difficult to do this in the carry on.
The security aside, so I'm wondering that other things that they generally can tell about people's life, or behavior, other things. I wonder. I haven't looked at the data and don't know how it looks like, but I'm just wondering. I'm curious to know.
I see. So in addition to what, in addition to, like you said, in addition to security and privacy research, there are other areas of research. One example is sort of HCI research. We have an active project right now where we try to understand people's perception about IoT devices and their privacy. For example, are people okay with a camera sending traffic when they're not around? Or are people okay with a device sending data to a somewhat untrustworthy country or company? Are they okay with it? What kind of device are people okay with when these devices talk to some untrustworthy, what seems like untrustworthy companies or countries? So this is another area of research. There's more human focused. We also have other projects that are a little bit more healthcare focused, where, for instance, IoT devices review patterns of life habits particularly about users in general, potentially. For example, when you're awake, when you're asleep, this kind of pattern can be shown by network traffic. You will see peaks of traffic when you're around, but the traffic rate is much, much lower when you're asleep. So patterns like this can potentially be used to infer human behaviors. On one hand, it is a privacy risk. We have a PETS paper about it. But on the other hand, it is a potential tool to infer, life habits, well-being of users. Say, for instance, whether users are sleeping too late, and can be used for, say, for instance, patient monitoring.
All right, great. Thank you.
Great questions. Thank you.
Thank you. So we have 3 minutes. I want to give the panelists also a chance to ask questions or, discuss whatever you think is important. Or I still have questions on my list, but
I see a question for IoT Inspector. A question was, does the tool expect certain messages or formats from the IoT devices to tell this is IoT device, this is not? Excellent question. No, it doesn't expect anything. In fact, it is so hard to identify devices in the first place. Whether a device is IoT or not, we don't know. What kind of IoT devices it is, we don't know. We have heuristics. Number one, we rely on user input. The users tell us. Number two, we gather various signals like, UPnP or MDNS messages where devices would broadcast who they are in some cases. Or, if devices use plain text HTTP, you can intercept the user agents. But there's like really no known techniques for inferring device identities in the wild. There are a lot of papers on building classifiers to learn devices' identities, IoT devices' identities in the closed world systems, where researchers would buy dozens of devices and, do training and cross-validation within their set. But we haven't seen any work on doing device ID identification on a large set. So it's actually a very hard problem to identify devices, what kind of they are, what manufacturers they are. Thanks for the question.
Thank you. Yes, so I had this question about experience sampling, which is something that we always have trouble with. Like we find that the subjective data, or we always have to collect this data from users. But first of all, there are problems with this with the applications themselves, and the second is how how reliable the user's responses are. So I see that in the paper that some applications were investigated in a study to see what they offer, and so my first question is, were all of these applications like free, or they were paid? Because I think there is a difference between the two, and there are services that, whether you looked at the services that actually are paid services, and I'm seeing many of my colleagues in the medical domain, they use those paid services. I wonder if you have also investigated those applications. We're also out of time. Just short. Is the author here? Experience sampling. I'm just checking who the authors were. Daniel and Aaron. Doesn't seem any of the authors are here. Okay, so we're also out of time. All right, so I'll ask the questions in the app. Thank you so much, everybody, all panelists, authors, presenters, and audience for attending this session. Have a great day, evening, night, wherever you are. Thank you. Thanks.
Thank you.
Bye-bye.
Bye.